Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 6.6, Combining Transformations Notes. Now, let's see if the audio is working this time. So, recall transformation of sine and cosine, right from the formula sheet. When you're looking at combining transformations, think back to Chapter 4, Transformations, A, B, C, D. This is what it looks like for the sine and cosine function. Now, this is a review of Chapter 6.5, what we just did. Now, note here, A is amplitude, not vertical stretch. B is the horizontal shift, which is related to the period, what we want to talk about. C is the phase shift, and D is the vertical displacement. And remember, it's CBAD when we're drawing it. Okay, so period DAC. Now, quickly sketch one wave of y equals 5 sine, bracket, 1/2, bracket, x minus pi over 2, close bracket, plus 1. State the coordinates of the maximum and minimum. Now here, A is 5, B is 1/2, C is pi over 2, and D is 1. Now while I'm doing this, I expect you to grab your graphing calculator and graph this. It's not a conversation, just do it. So, original graph will look like this. Chapter 6, Section 4. That's one sine graph. That's horrible. Let me make that a little less unstraight. This will be 5. All right. Now, what are we doing here? Oh, the coordinates. Pi over 2, 1. 3 pi over 2, comma 1, minus 1. That'll be the maximum and minimum. Now, what do we do here? Well, the big thing is the period. Period is 2 pi divided by b. Now, in this instance, that's 2 pi divided by 1/2, which is 4 pi. Okay? So that becomes important in 1 minute, but I'm actually getting ahead of myself. First things first, I want to do C. The phase shift. So this entire graph moves over pi over 2 to the right. So it would look like that. Then the period is 4 pi, which means it gets stretched. So it goes something like, actually no, let me change the color. Pink. So it's stretched out like that, and notice the wavelength of the period is now 4 pi. Then we go on to the amplitude A. I'll make this orange. 5 up, 5 down. So a vertical stretch of 5, which we now call the amplitude. So if we're on the x-axis, nothing happens. Remember, it's the y value gets 5 higher or 5 lower, depending if it's positive or negative, 5 times. And that's a horrible graph. Curve. Let's see if I can make that a little less bad. Okay. And then the last thing is our d value. We go up 1. So everything moves up 1. And there we go. And that's our graph. Okay. Now, what's our new maximum and minimum? Well, you can read it off the graph. That is 3 pi over 2 and 6. And that is 3 pi. Halfway between 3 and 4, that is 6 pi over 2, 7 pi over 2, or 3.5 pi, and minus 4. Now, for those points, remember, I really need you to be able to go x goes to x over b plus c. So this is x divided by 1/2 plus pi over 2. So that, oh, sorry. Apologies, that is. The original x coordinate was pi over 2. divided by half, that becomes pi. And here you're going, okay, common denominator, that's 2 pi over 2. So that's 3 pi over 2, our new x-coordinate. Now y, we do the exact same thing. ay plus d. This becomes 5 times 1 plus 1, which is 5 plus 1, or 6. Now, you can do it for the minimum value. I'm not going to bother doing that. Okay? Now, that's a review of 6.5. 6.6, the meat of it is the next couple of graphs. Find the equations of the following. I'm going to pause the recording here. So once you review this stuff, and once you're ready, we'll go on to 6.6. Okay? Good luck.